Hello students, I am Sachitrakar. Welcome to Cars Physics. We are continuing work, power and energy. Okay. In just previous lecture we have discussed conservation of mechanical energy. Conservation of mechanical energy. Okay. So we have discussed all the concepts about conservation of energy, and we have discussed how to solve numericals on the basis of conservation of mechanical energy in brief. Okay, and also we have discussed some numericals on the basis of conservation of mechanical energy. Okay, again I would like to advise you students who have not gone through the previous lecture, go through that. Lecture number 7, work, power, energy. Okay, lecture number 7, work, power, energy. Go through it first. And after going through the numericals, you can understand the fundamentals easily. And this lecture also, in this lecture, we are continuing conservation of mechanical energy. And in this lecture, we will do some fundamental numericals. But to understand these numericals, you should go through the previous lecture, means lecture number 7. Okay, this is part 2 of discussion of conservation of mechanical energy, some numericals only. Okay, then our final output, the last output of previous class discussion is to find the unknown value by applying conservation of mechanical energy. The final principle is sum of final potential energy and final kinetic energy is equal to sum of initial potential energy and initial kinetic energy. Okay, this is our final discussion. Okay, in previous lecture we have discussed how this can be concluded. We have discussed all the concepts. Okay, sum of potential energy and kinetic energy. See, mechanical energy is sum of potential energy and kinetic energy. Okay, so energy, mechanical energy is conserved. Conservation of mechanical energy, and sum of final potential energy UF and final kinetic energy Kf is equal to sum of initial potential energy UI, I per initial, and initial kinetic energy Ki, UI and Ki. Okay, let's start numerical. This is lecture number 8. Okay, question number 1. First question. Easy question, but go through the previous lecture. Again, I am repeating. See, suppose this is an inclined plane. This is an inclined plane. Okay, so this angle is 90 degree. This angle is given theta, means 37 degree. Okay, I'm not writing the questions. You can take it. Okay. This is a block of mass small m. A spring is attached to this block and connected to a string, and the string is passing over a pulley, and a body of mass m, capital M, is suspended from the end of the string. Okay, spring constant is k, and some data we may use. Okay, I am not giving value of m and m. This surface is rough surface. This surface is rough surface, and coefficient of friction mu, let it be 3/4. Okay. Then how can you frame the question from the diagram? A block of mass m is attached to a spring of spring constant k. Then the spring is connected by a string. String is passing over a pulley. And a block or a body of mass capital M is suspended from the end of the string. Okay, then what is asked? Find relation between M, capital M, and M. Small m means mass of block is small m, so that the block means mass is small m just starts its motion up the inclined plane. This is our question. We have to relate between small m and capital M. What should be relation between capital M and small m? So that the block of mass small m just starts moving up. Starts moving. Okay. And as per, see, this surface is rough, coefficient of friction is given, and as we know, this body suspended from string will exert a force due to its weight. Then we have to find relation between M and F. Suppose options are given. M is equal to 2M. Option B. M is equal to 2/3 small m. C. M is equal to 2M. M is equal to 2/3M. And M is equal to 3/5M. And finally option D. M is equal to 4/5 into small m. Okay, just try it once and then go through it. So what we have learned from concept of friction, static friction. If a force is applied to move a body, means to start the motion, then the force is opposed by frictional force, static frictional force equal, as you know. Okay, with gradual increase of applied force, static frictional force increases equally. Okay, and finally static frictional force reaches its maximum value, which is called as limiting friction. So at the limiting stage, applied force is equal to maximum value of static friction, or applied force is equal to limiting friction in magnitude. Okay, so the body just starts motion if applied force, magnitude of applied force becomes equals to magnitude of limiting friction. This is our concept from friction. It's all right. Okay, could I recall it? Fine. Okay, so when the weight of the body of mass m acts in downward direction, obviously the spring will get elongated. Means spring will open. Means configuration of spring changes. Okay, see, weight mg, tension is T, here also tension is T. The spring will first open, means the length will, spring will elongate, means configuration of spring changes. Suppose the spring is elongated by X, spring is elongated by x. Okay, so spring is elongated by x means spring force will be in opposite direction. That force is kx. Okay, the body will start motion. You see, when the body starts moving upward, means at the stage of limiting friction. Value of limiting friction, let's take Fs. Limiting friction is Fs. Mu into normal reaction. Okay, and you know this fundamental. If you take an inclined plane, this angle is theta. Suppose this is a body of mass m, then weight of the body acts in vertically downward direction and normal reaction is perpendicular to the surface. Name is normal reaction. Then this angle is theta. Component of weight opposite to the direction of normal reaction is mg cos theta. And another rectangular component parallel to the plane is mg sin theta. Is it clear? Okay. Now, tension is equal to spring force. Okay. Then, in this direction, tension which is equal to kx will act. Magnitude of tension is equal to magnitude of spring force because it is opened. And then, thereafter, force will be pulling the body in upward direction on the inclined plane. Is it clear? Okay. Then frictional force, when the body tends to move up, frictional force acts in opposite direction means opposes the motion. And at limiting stage, the body starts its motion, just starts. Then what is free body diagram? What is free body diagram? You just imagine, this is the inclined plane, here is the body. And in downward direction, means in this direction, the force is mg sin theta. And in upward direction, this is kx, tension, T is equal to kx. And again, in downward direction, there will be limiting friction, motion upward, starts the motion in upward. Okay, then frictional force will oppose motion. Frictional force is mu r, then mu. Here normal reaction is equal to mg cos theta. If the body just starts motion, then upward force is equal to total downward force. So we have to take the state of equilibrium. The body just starts motion. So resultant force is 0. Just starts motion. For accelerated motion, applied force should be greater than opposing force. You know it. Okay. Then, to just start motion, total upward force is kx. Is it correct? Total downward force is mg sin theta plus frictional force mu mg cos theta. Okay, then kx is equal to mg sin theta. See, theta is given 37 degree. Again, you know, if angle is 37, this angle is 90, then this is 4, this is 3, and this is 5. Then sin 35 is 3 by 5 plus mu is given 3 by 4. Mg into cos theta, cos 37 is base upon hypotenuse means 4 by 5. Then we can calculate for kx 3 mg by 5 plus 4 get cancelled, 3 mg again divided by 5. So 3 by 5 mg plus 3 by 5 mg means 2 into 3 by 5 into mg. So it comes 6 mg by 5. So you have got it. Kx is equal to 6 by 5 mg. Okay. Then we will apply the concept of conservation of mechanical energy. U final plus kinetic energy final is equal to initial potential energy plus initial kinetic energy. Okay. Then what is final potential energy? What is final potential energy? See. If spring is elongated through x, then the body has moved before starting motion. Body has moved through a distance x in downward direction. If this is baseline, then body has moved through a distance x in downward direction. Means potential energy of this body decreases because it moves below the baseline. So change in potential energy means decrease in potential energy is minus mgx. If the body moves up the baseline, then potential energy increases positive. If the body moves down the baseline, then potential energy is negative. Okay, and formula for potential energy is mgh, and here the body has moved down the baseline through a height x. Is it clear? Plus final potential energy. The spring has elongated through x. So potential energy stored in the spring is kx square. And as you know, spring energy is always positive. Plus final kinetic energy is 0 because the body just starts motion. So final kinetic energy is 0. Again, initial potential energy ui. This is baseline. For this body, this is baseline. So this body has its own position. This body also initially at its own position, means on baseline. So initial potential energy is 0 and initial kinetic energy is 0, but because both are at rest. Okay. Then mgx, bring it to, I am writing again, minus mgx plus half kx square is equal to 0. Okay. So mgx is equal to half kx square. Bring it to right side, negative becomes positive. Okay. Then what is kx? Kx we got mg, x square cancel. Then mg is equal to half kx and mg is equal to half kx. Kx is 6 by 5 into small m into g. G get cancelled and capital M is equal to 6 by 2 is 3 by 5 m. This is our relation. Thus option is C. Option is C. Is it clear? So option is C. Capital M is equal to 3 by 5 into small m. Okay. Two easier questions, just go through the fundamental. Lecture number 7, work for energy. Okay. Next question. I think it is clear for you all. Okay. Question number 2. Some easier questions and conceptual also. And helpful questions also. Question number 2. You just see. This is an inclined plane. Again here, angle of inclination is 37 degree. This angle is 90 degree. And here surface is smooth. All surfaces are smooth. means coefficient of friction is neglected. Coefficient of friction is neglected. We have to consider like that. Okay. And here, this is a vertical rigid support. A spring is attached to the support. Okay. A spring is attached to the support. Spring constant is K, and a small block of mass M is attached to the spring. Okay. We may use numerical data also. I am writing the question first. You understand? The body is compressed. This is body. The body is compressed first. Compressed against the spring through. The body is compressed against the spring through 1 centimeter. Okay. Then released. Find the height on the inclined plane where the body will reach. Okay. Then given some data we may use. One data is through 1 centimeter, the spring is compressed through 1 centimeter. You just take given mass of the body is 2 kg, any value you may take, or 5 kg or 1 kg, any value you may take. Mass of the body is 5 kg. Okay. And spring constant K is equal to 100 Newton per meter. Okay. Okay, this much. The spring is compressed through 1 centimeter, then released. Then we have to the height to which this body reaches. Okay. See, when the body is compressed, the configuration of spring changes. The spring is compressed and potential energy stored in the spring, and when it is released, the potential energy stored in the spring is converted to kinetic energy of the body. Thus the body moves towards the incline, and thereafter the sin surface is smooth, the body moves up and finally stops here. Why the body stops? Because downward force on the body is mg sin theta, as we have discussed in just previous numerical. So, retarding motion, when the body moves up, motion is retarded due to component of its weight parallel to the plane, and body reaches at this position. Okay. So, we have to find the height. We have to find the height to which the body is raised. We have to find this much. See, this is also right angle triangle. So this angle is 37, this is h, and let this distance. Okay, height is asked, or you may write, find the distance. Find the distance on the inclined plane. Distance on the inclined plane where the body will reach. Then if it is asked to find distance, we'll take L. L is distance of the inclined plane to which the body rises. It may be asked to what height, or it may be asked to what distance the body rises on the inclined plane. Okay. You understand the concept first. Spring is compressed. Thus configuration of spring changes. the spring, in the spring, potential energy stored, and when it is released, the potential energy stored in the spring is converted to kinetic energy of the body. With that kinetic energy, body moves up to the bottom of the inclined plane. So there is no friction. So kinetic energy remains constant, or speed remains constant up to this position, up to bottom of inclined plane. Thereafter the body moves up. When the body moves up, the motion is retarded due to the component of weight mg sin theta. Motion is retarded, and at this position velocity becomes 0, and finally body comes to a temporary rest at this position and then moves down, because this force will pull the body down. We have to find this distance L. Okay. Then if this is a right angle triangle, see, this is L, this is H, this angle is 37 and this angle is 90. Okay. Then if it is asked to find L, means distance on the inclined plane, then simply we can write H is equal to L sine theta. Theta is 37. Theta is 37, and as we know, this is 3, this is 4, this is 5, this angle is 37, this angle is 90. Then H is equal to L sine 37 means 3 by 5. So H is equal to 3L by 5. We may calculate H, or if it is asked to calculate the distance, we will calculate L. Okay, then just apply the principle of conservation of mechanical energy, final potential energy plus final kinetic energy is equal to initial potential energy plus initial kinetic energy. Okay, final potential energy, see, body will reach at this position, means to a height h, this is baseline, this line is baseline. Body has moved to a height h above the baseline, so potential energy is gained by the body, means positive. Okay. Then final potential energy is mgh, and final kinetic energy is 0. Body comes to rest. Okay. Final kinetic energy is 0. Then initial potential energy of the body is on the baseline. So initial potential energy is 0, and initial kinetic energy, see, potential energy stored in the spring is converted to kinetic energy of the body. So kinetic energy of the body is half kx square. This is the energy stored in the spring. This energy is converted to kinetic energy of the body. This is basic concept. Now we can calculate L or H. Suppose it is asked to find distance, then this is mg, in place of h, so we can write 3L by 5 is equal to half k x square. Okay. Then mass is given 5 kg. In place of g, let's take 10 meter per second square into 3L by 5 is equal to half k. K is 100. K is 100, and the spring is compressed through 1 centimeter, means x is equal to 10 to the power minus 2 meter, and this is x square, means 10 to the power minus 4 meter square. Is it clear? Now just solve to get L. 5 get cancelled, 0 get cancelled, then 3L is equal to 10 by 2 is 5 into 10 to the power minus 4, and L is equal to 5 by 3 into 10 to the power minus 4 meter. If it is asked to calculate H, then no need to take 3L by 5. You can just calculate H. Okay. You can just calculate H, angle is not required. But if it is asked to calculate distance on the inclined plane, then we will take, in place of h, L sine theta. L sine 37. Then calculating it 5 by 3, it is very easy, approximately 1.6 into 10 to the power minus 4 meter. This is your answer. Is it clear? Is it clear? Fine. Okay. Next question. Next question. Easier question, chain problem, chain problem. Just understand the concept, everything will become easier. Friction may or may not be given. If friction is given, then we will calculate accordingly. If friction is not given, smooth surface, then we have to neglect friction. Okay. This is your question. This is a horizontal surface. Suppose surface of a table, surface of a table, and this is ground. This is ground. Means baseline. Okay. A chain is placed like this. And rest part is suspended at the edge of the table. Okay. Then what is given and what is asked? An uniform chain, I'm writing here. An uniform chain of mass m, and we may give we may take value, it is given, I am taking variables, and length L is lying on a tabletop with half its length is hung at the edge of table. What will be speed of the chain if it completely slips out from surface of table? This is your question. An uniform chain of mass m and length L is lying on a tabletop. Okay, on a tabletop with half its length is hung at the edge. This is half length. Okay. Edge of table. Then what will be speed of the chain if it completely slips from the surface of table? Okay. Just take this is baseline. This is baseline. And this is the initial condition of the chain. Okay. So, for length L, mass is M. So, M by L is mass per unit length. Mass per unit length. Okay. So we have to consider here, we have to take here center of mass, by which the problem will be made very easier. We have to take center of mass. Of course, we will discuss center of mass in rotational motion. Okay, very soon it may come. Okay, So center of mass, the basic concept, just keep it in mind. Basic. For a regular body, the position of center of mass is at geometric center for a regular body or a symmetric body. Position of center of mass is at its geometric center. In this numerical, just apply this. See, half of length is suspended, means this length is, the suspended part is L by 2. Okay. Then obviously, if M by L is mass per unit length, mass of this chain is M by 2. If total mass is M, then for half length, mass is M by 2 because chain is uniform chain. Okay. Then where the mass is assumed to be concentrated at the center, means at the geometric center. If total length is L by 2, then position of center of mass is at a distance L by 4 below the baseline. Now, weight of this part will pull the chain in downward direction. And since here we are neglecting friction, mu is 0, not given. Friction is not considered. Of course, we may consider friction. Okay. Then the whole chain will slip out from the edge of table, and when it completely slips, final end is on the edge and total chain is like this. So total length of the chain is L, and now center of mass is at, this is L by 4, very sorry, this is L by 4. Okay, this is L by 2, I am right, I have taken right. Total length is L by 4 and position of center of mass is at a distance L by 2 is total length. L by 2 is total length of the chain, part of chain which is hung at the edge of table, and center of mass is at center, means at a distance L by 4 from the edge of table or at a distance L by 4 below the baseline. Okay. Now, total chain slips out of the edge, and now total length is L and center of mass will be at this position, means at a distance, if total length is L, then at a distance L by 2 from the baseline. This is total mass. Okay. Then again apply the concept U final plus kinetic energy final is equal to initial potential energy plus initial kinetic energy. Okay. You see the initial condition. This is initial condition. 50% or half the chain is hung at the edge, and this is final condition when whole part of chain on the table slips out of edge. Okay. Then what is final potential energy? See, now when the chain completely slips out, this is center of mass at a distance L by 2 below the baseline, means potential energy is negative mg L by 2 minus mg L by 2, distance is L by 2. Okay. Then final kinetic energy is half mv square, because when the chain is slipping out and finally slips out from the edge, then according to conservation of mechanical energy, total potential energy and kinetic energy final is equal to total initial potential energy and initial kinetic energy. Then final kinetic energy will be mv square, half mv square, because the chain is moving downward with a speed v. And initial potential energy, see, this part is from the edge of table, this part is from the edge of table. Okay. Then mass of this part potential energy mgh, mass of this part is m by 2 into g, sorry, again negative, below the baseline, negative, minus m by 2 g h. Here h means distance from baseline, means L by 4, and initial kinetic energy is 0. Because the change is at rest initially. Now this let's solve to get speed of the chain. This is minus. Okay. Then m get cancelled. Then v square by 2 is equal to minus gl 4 into 2 8, bring it right side, plus gl by 2. Then v square by 2 is equal to, this is 8 minus gl plus this is 2 plus 4gl. Then v square by 2 is equal to 3gl by this is 8. Okay. Then v square is equal to 3gl by 4. To cancel 8 means 2 into 4 is 8. Then v is equal to square root of 3gl by 4. 2 is here. Just apply this concept. Okay. Then similarly, another method to solve chain problem. Okay. Is it clear to you? Okay. Just apply the concept. Everything will be made easier to solve the numericals on the basis of conservation of mechanical energy. See, I am giving first the concept. This is a semicircular wire. Radius of the semicircle is r. Okay, we'll find the method. We'll apply the method to find center of mass. This is a semicircular wire. Uniform semicircular wire. Uniform. Total mass is m, radius is r, this is center, radius is r. Then center of mass of this semicircular wire, uniform semicircular wire, means total mass is assumed to be concentrated at this position, and this is at a height h. From the baseline, this is baseline, then h is equal to, here in this case just remember 2r by pi. Position of center of mass of uniform wire of radius r, semicircular shape uniform wire, then its position of center of mass is at a height h from the baseline. This is baseline. Okay. And the position of center of mass is at a height h is equal to 2r by pi. Just remember it. We'll derive, we'll apply in rotational motion. Okay. Let's consider this is a cylindrical pipe which is bent in the form of semicircle, and this is a chain, uniform chain inside the pipe. This end is P, this end is Q. Okay. We are giving support. The chain is initially like this. Okay. Then what is total length of the chain? This is baseline. This end is supported, closed. This end is also closed. Okay. Then radius means average radius of semicircle is r. Average radius of semicircle is r. Okay. Then L is equal to pi. Then what is asked? the chain is allowed to move at the opening Q. Find velocity or speed of chain when it completely when it just completely comes out of the tube. Okay, this is a tube inside which the chain is kept, uniform chain. Okay, imagine M is mass of the chain, uniform chain, and length of chain is pi r. This is initial condition of the chain. Now we have taken this is baseline, this is baseline, this is baseline. This end is closed, no opening is here, but this end is opened. This end is opened. Now it is opened. We are neglecting friction, so the chain will come out through this opening Q, and when it finally means completely comes out, it completely comes out, and at the end means opening Q, it is just final end means this end at P is reached at end Q. Then when it falls, it will move with a velocity or speed v, and this is center of mass of the chain. If total length is L, then position of center of mass is at a distance L by 2 from the baseline. It is final condition. Okay, then just apply the principle. Final potential energy plus final kinetic energy is equal to initial potential energy plus initial kinetic energy. Okay, then what is final potential energy? See, mass of the chain is m, g, and height below the baseline is L by 2 minus, because mass is below the baseline. So negative potential energy is negative, and final kinetic energy is half mv square. Is it clear? Final condition. Then initial potential energy. See, when we consider this chain, within this case, uniform where? Uniform chain, then this is initial position of center of mass is at a height h, and where h is equal to 2r by pi, then initial potential energy is mgh. In place of h, we may take 2r by pi, and initial kinetic energy is 0 because initially the chain is at rest. And finally the chain comes out when the end P reaches at Q, then the chain completely comes out and it acquires a speed v. Then just solve it, you will get your answer. Minus mg L by 2 L. Okay. L is total length is pi r. Then this is pi r by 2 plus half mv square is equal to mg into 2r by pi. Okay, m get cancelled. Then v square by 2 is equal to 2gr by pi. 2gr by pi. This is negative, bring it to right side, plus pi gr by 2. Just solve it. Then v square by 2 is equal to LCM 2 pi 2gr plus pi, so 2gr, no, it will be 4gr pi 2 pi, this is pi, this is 4 here and here. This is 2. LCM is 2 pi means plus pi r square. 2 pi, pi r square here. Then 2 get cancelled. And v square by 2 is equal to gr. Bring it common and inside bracket 4 plus, sorry, v square. 2 is cancelled, v square. 4 plus pi square divided by pi. Then v is equal to square root of gr into 4 by pi plus pi square 2 pi 4 and this is 2, so pi square, okay. 4 by pi plus pi square by pi is pi. Okay, this much. 4 by pi into pi. Okay, we will consider friction also. So we will apply the concept of friction. Okay, you can do it. Thanks, my children. In next lecture, we'll meet again with a new chapter. Thanks.